This study aims to explain how students think as they do problem solving in physics, and more particularly, how students use their knowledge of mathematics not only as a computational tool but also as a reasoning tool. So they have used the theoretical lens of epistemological framing to understand what's going on in a student's problem solving activities and what are a students' reasoning that they offer when making a mathematical argument in the context of physics. So students have different subset of knowledge and mathematical toolbox that they can activate to work in a situation. But we cannot directly observe a student's thinking. Instead, by listening to a student's reasoning and conducting discourse analysis, we can find a window to a student's mind and characterize the ways that they think as they link their ideas to activate in a situation. Framing is a context dependent process, which means different factors can alter a student's thought process. These factors can be internal, such as our expectation, or external. Before we continue to talk about the paper, let's consider an example from a real life scenario. So, when we enter a fast food restaurant, our expectation unconsciously guides us to a set of activities, such as starting to search for the menu on the wall, select our food, pay for it, and then use hands to eat it. Our expectation as how to behave in a fast food restaurant can be so much dominant that may prevent us from noticing other external cues that are already in the environment, such as a sign next to the menu or on the entrance door which says, the restaurant tonight is out of this specific sandwich. And so these factors, either internal or external, are also present in other environments, such as a classroom environment. For example, in a classroom environment, a student's state of mind can alter as a result of an instructor student frame interaction, or a student's student frame interaction, or interaction with other artifacts in the classroom, such as the problem statement. I will provide links to these studies in the reading discussion of week 6 in case if you are interested to learn more about these interaction effects. So, students in this study have already taken intermediate level courses of quantum mechanics, classical mechanics, and electricity and magnetism, which is a good indicator that they have enough background knowledge and mathematical skills to participate in problem solving activities. The data is mostly coming from group homework problem solving sessions. And as we discussed before, there are many interactions going on in a classroom setting, especially in a group problem solving session. And researchers use ethnographic methods to analyze these high level interaction environments where any small piece of data may contain important information. So, researchers not only pay attention to students' discourse, but also to their behaviors, gestures, hand motion, or even the way that the students make eye contact while communicating with each other. They also mentioned in the paper that contrasting cases are helpful with determination of a student's frames. A contrasting case can occur, for example, when two students have two different views on the same problem and they are not in agreement with each other. So, in an ongoing discussion, to make their point, each student is going to support his or her argument and becomes more explicit in the use of mathematics. And this makes it easier for the researcher to identify what frames students are in and what is the nature of activities that is going on during that moment of problem solving procedure. So, by careful analysis of a students' variance and reasoning, they have identified 4 epistemological framing, which are calculations, physical mapping, invoking authority, and thematical consistency. Okay, so let's consider an example to become better familiar with the characterization of each of these 4 frames. So in this problem, it asks to calculate the amount of charge of a capacitor such that if we place an electron in the middle of the capacitor, it does not move in any direction and it stays there. So for this problem, a student may start by drawing a free body diagram and say, okay, so the gravitational force is downward, and if the charge is not going to move, it means that the charge does not have an acceleration and it's in equilibrium state. So here there should be an upward force that cancels this downward force, and this means that the direction of the electric force is going to be upward. And then the student can proceed into the problem by mapping this physical story to a mathematical representation by writing down that mg equals F sub E. But then, when wanting to replace the electric force, the student may not remember the formula. And then the student may open a textbook and find the formula and then replace that guy here. And then continue to replace the given numbers and do a couple of algebraic operations to solve the equation for the capital Q and find an answer. Now let's see what frames the student used in order to solve this problem in this way. So initially, the student started with a free body diagram and think about what does it mean for a charge to be in equilibrium, and then how is that related to the concept of force. So a student, while making this chain of reasoning, was in a physical mapping frame. And then for a short time, the student moved to a calculation frame to map this physical situation into a mathematical template of gravitational force being equal to the electric force. And then the student used the authority frame, referred to the text, find the formula and replace it into the equation. But the student did not further justify or provided any reasoning. And that's due to the reason that how the student is framing that situation. The student thinks that the information coming from a textbook is trustable and does not require further justification. Now imagine that when the student is about to use the authority frame, the instructor arrives and asks the student to find an expression for the Coulomb's force without relying on the authority frame, which is the textbook. So the instructor reminds the student about the mathematical form for the gravitational force. And the reason is that in this hypothetical scenario, the students have already covered this topic and they are familiar with. So the student writes down the equation of gravitational force, and in a discussion with the instructor, then the student is able to find out what is the electrical analog to the mass. And then he figures out that that could be the charge. So he replaced the mass with charge. And then the instructor also explains that in both scenarios, forces fall off with respect to distance in the same way. And then the remaining is just a constant. So the instructor, during this part of the problem solving, nudges the student to frame the situation as mathematical consistency, which means that mathematical relations are reliable to be applied across different contexts. So, framing studies can better explain the dynamic and the richness of a student's reasonings. This is important as it gives insight to a student's thought process because a student's difficulties may not be due to fundamental inability to understand a concept, but it could be due to a framing issue, such as not being able to find the frame of the problem statement or not being able to shift into other frames of thinking. Framing is a highly context-dependent process, and what determines a productive frame depends on that moment of the problem-solving process. Also, different frames can be productive for different students. One may benefit more from a calculation frame, whereas another student may benefit more from a physical mapping frame. This framework can be useful for instructors to better analyze the moment by moment of frame activities in their classrooms and, as a result, better nudge students towards more productive frames and help students to recover from errors.